Hello everyone. It is an incredible honor for me to impart my understanding of the topic equation of the circles to all of you here who are currently watching this video. I will also spill some tricks and tips in hopes of improving everyone's grip of this topic. So let's not waste any more time and get on with the presentation. First of all, let's review the formula to find the area of the circle. And as you can see, there are two different formulas presented on the screen, which you can use interchangeably. The first being pi r squared and the other 1/4 pi d squared. If you're familiar with the relationship between the radius and diameter, then you should be able to tell that both these formulas I've just mentioned is actually just one and the same, but only with a different independent variable. You'll see what I mean if you substitute 2r to the d in the second formula, which should lead you to the first formula. Done with the basics and time to explore new grounds, particularly the equation of the circle. In order to construct this equation, we have to find the point at the center and the radius. It is fairly easy to discover the coordinates of the circle, but I can't quite say the same for the radius. And so, this is going to be our main focus for today. From this diagram, if you could connect the origin to any point in the circle and draw the horizontal and vertical line connecting both points, you obtain a right-angled triangle. The good old innocent days when we were asked to find the hypotenuse of a right-angled triangle. How I miss them. Anyways, let's not be sidetracked here. All of you should be exceedingly familiar with this equation. And yes, I am talking about the one and only Pythagoras theorem. Thus, we can say that the equation of the circle is equivalent to x squared plus y squared equals to r squared, r representing the radius. Though there are slight changes made to the equation when the midpoint of the circle is not located at the origin, thus, we have to carefully analyze each component. We are still able to utilize the Pythagoras theorem, but we have to think about the base and the height of the right-angled triangle. First glance, it looks intimidating, but after careful observation, you could tell that the base of the triangle is the horizontal distance from the y-axis to the point of the circle deducted by the x-coordinate of the midpoint. The same can be said for the height, except this time it is the vertical distance from the x-axis deducted by the y-coordinate of the midpoint. There are 2 points shown in the picture, so what we should do is deduct 4 from 10 and deduct 7 from 12, squaring both results and adding both of them together to obtain the square of the radius, which is 61. Of course, not all questions is going to be as easy as ABC. Thus, let's move on to another possible scenario where they will give you the equation of the tangent line and the coordinates at the center of the circle, asking you to find the distance between the midpoint and the point of intersection. To solve this problem, you could use the formula to find the distance between a point to the line in order to obtain the radius. And all we have to do is to input all the necessary elements. In this question, we are given the equation of the tangent line and the coordinates at the center. If you couldn't already tell, the circumstances are similar in format to the one we have just previously discussed. The first step to solving this problem is to move all the variables and constant to one side of the equation. All of you must be wondering why the equation is not identical to the one presented in the graph. Well, this is because I multiplied the entire equation by the highest number from the denominator of the original formula, thus converting it into a whole number. If you would like to use the original equation, you're welcome to do so. The next step is to input all the values into the distance formula shown on the screen, giving us the radius. Construct the equation of the circle with the two essential elements we obtained, the radius and the midpoint of the circle. The second example involves the use of the area formula we have previously discussed at the start of the video. What we currently have in hand is the area of the circle and the coordinates at the midpoint. The only element lacking is the radius of the circle, and we can obtain it by dividing the area with the pi value and squaring the answer. You know the drill. Input the radius and the coordinates into the circle equation if necessary. Okay, for this slide, I want you guys to pay close attention to the tangent line and what it represents. Instead of facing this question headstrong, we can utilize a trick in order to obtain the radius. With the y-axis as a tangent, this indicates that the normal will be the horizontal line. As we are finding the radius, the horizontal line will extend from the point of intersection with the tangent line up to the center, while the x-coordinate represents the horizontal displacement from the y-axis. Thus, based on this fact, we can safely conclude that the radius is equivalent to the x-coordinate. So, this is just a simple test for you guys. I'm going to give you about 5 seconds for you to digest the question and come up with an answer. If you think it's too short of time span, you're free to pause the video and take the time you need. Okay, you guys might have some ideas as to what the answer might be, and some of you might have even guessed it, might have even gotten it. But for those of you who still doesn't understand, please don't feel discouraged. I also experience a lot of difficulties in this topic, and everyone takes different amount of time to digest it. Okay, on with the solution. With the same thought process from the slide before, but with the different tangent line on the tangent line on the x-axis, the radius will be the normal from the point of intersection to the center, equivalent to the y-coordinate at the midpoint of the circle. Finally, I have one last formula I wish to share with all of you. I know. All of you are sick and tired of adding this complicated equation to the already long list. But for this one, you could just refer this equation to the equation of the circle. To find the tangent line which passes through the given coordinates of the circle, all you have to do is to separate the components of the square and replace one of the x and y variables with the given coordinates on the circle, while the value of the R square is unaffected. The given coordinates of the circle is 1 and 2, and the circle is located at -4 and 4. So all we have to do is to input these values to the equation on the screen, and we will be able to obtain the line equation of the tangent line. It's much easier than you think, right? I hope all of you can get something out of this video. Thank you for your attention, and catch you later.